This question is about time of flight mass spectrometry. The first thing we're being asked to do is define relative atomic mass. So this is quite a tricky definition. There's a lot of features to it and it needs to all be correct. So it's the weighted average. We're averaging our masses of isotopes, the weighted average mass of all the isotopes, but we do need to weight them because there might be more of one isotope than another. And then it's relative to, so we do a divide sign, and that's 1/12 the mass of an atom of carbon-12. And all those features are important for that bottom line. 1/12 the mass, an atom, carbon-12. The next part of the question says that we are ionising krypton using electron impact, where we knock off an electron. It has 4 peaks, that tells us it has 4 isotopes, and it's asking us to calculate the relative atomic mass to 1 decimal place. At this point, I'm going to go down to the bottom line. I'm going to write 1 decimal place underneath to remind me at the end to give my answer to 1 decimal place. Then I'm going to remember that this calculation is where I do this weighted average. So I'm going to times the mass by the abundance, and then add those all up because I'm doing an average, but I'm weighting them according to their abundances. So I'm doing that. And then I'm going to divide it all by the total abundance. Now, notice if you do a quick look at these don't add up to 100. So you add them up, you'll get 43. So your bottom line is going to be 43. You type all that in your calculator, and your calculator will say this number, 84.090698, but we have to give our answer to 1 decimal place, so it becomes 84.1. We must follow the instructions in the question. Then the next part of our question is about calculating, and it asks us to calculate the length in meters. So to do that, I'm going to have to use distance is velocity times time, because my kinetic energy expression has velocity in it and it doesn't have distance. They've given us the isotope they want us to look at, so it's the 84 chromium isotope. They've given us the kinetic energy and they've given us the time. Okay, they've also given us Avogadro's number. The first thing we need to do is work out what the mass of one isotope of 84 krypton is. Now 84 is the mass of 1 mole in grams. So the first thing I'm going to do is divide it by 1,000 times 10 to the minus 3 to convert 84 to kilograms. And then I'm going to divide by Avogadro's to find it for 1 atom or ion rather than a 1 mole. And if I do that on my calculator, because Avogadro's has been given to 4 significant figures, I'm going to keep this to 4 significant figures for now. I can keep it on my calculator screen as well. But 1.395 times 10 to the minus 25 kilograms. So that's our M for kinetic energy. Now, because we're trying to find distance, and distance is related to the velocity and the time, I'm going to have to rearrange the kinetic energy expression to say V equals. Now, if kinetic energy is a half times mv squared, then V would be the square root, because I'd have to get rid of that squared sign, 2 times the kinetic energy, so bring the half to the other side, it becomes double, divided by the mass. So I've got 2 marks so far. I'm going to put my numbers in. So it's the square root of 2 times the kinetic energy, which they gave us in the question, 4.83 times 10 to the minus 16 joules. And we're going to divide by the mass that we've just calculated. So on your calculator screen, you might want to do 2 times 4.83 times 10 to the minus 16 divided by answer if you've still got the mass on your calculator screen. If you do that and you remember to do the square root, you're going to get 83,218 meters per second, which gives us another mark. And then if we remember that velocity is distance divided by time, then distance is velocity times time. So we take our velocity that we've just calculated, we multiply it by the time given in the question, and we get 1.43 meters. Now, this doesn't ask for a certain number of significant figures, so a general rule of thumb for chemistry is give 3 if not asked otherwise. So 1.43 meters.